Assalamualaikum, it's me Ms. Fardiba from Peshawar Model School, Nashara branch. Today we will discuss law of mass action, which will be our fourth lecture from class 10th chemistry, and our unit will be chemical equilibrium. But before going to discuss our topic, I would like you to subscribe our YouTube channel so you will watch our videos continuously. Okay, let's look at the historical background of this law. This law was proposed by two chemists, Cato Goldberg from 1836 to 1902 and Peter Wagg from 1833 to 1900. These two chemists proposed this law in 1864. It was presented as a general description of the equilibrium condition after observing many chemical reactions. Let us look at the statement or the definition of chemical equilibrium. The rate or speed of chemical reaction is directly proportional to the products of the active masses of the reacting substances. In this definition, here are three phenomena. The first one is the rate or speed of chemical reaction. What does it mean by the rate or speed of chemical reaction? Speed of chemical reaction means that at which pace any chemical reaction is proceeding. The second one is directly proportional. As we studied in our maths and in physics subjects, that directly proportional means that at any chemical equation or chemical reaction, if one component is increasing, then the other will also be increasing, so that will be called the directly proportional. The third one is the active mass. What does it mean by the active mass? Active mass means molar concentration. Molar concentration means that how many moles of each reactant are reacting. So this definition means that if in any chemical reaction two or more than two reactants are reacting together, so the product of that, the active masses of that reacting substances will be directly proportional to the rate or speed of chemical reaction. Or we can say the rate of chemical reaction is directly proportional to the molecular concentration of each of the reacting substances. In this definition, molecular concentration. What does it mean by the molecular concentration? Molecular concentration means number of moles per decimeter cube is called molecular concentration. It means that at any dilute solution, how many moles of each reactant is dissolving or reacting. Or active mass is also known as the molecular concentration or molar concentration. Okay, this is the second definition, or we can say the second form of this definition. The rate of chemical reaction is directly proportional to the molecular concentration of each of the reacting substances. Means that in any reactions, if there are two or more than two reactants, so the molecular concentration of that reacting substance will be directly proportional to the rate of chemical reaction. Means that if the molecular concentration of that reactants are higher or more, then automatically the rate of chemical reaction will be faster. And if the molecular concentration of that reactant is lower, then the rate of chemical reaction will be slower. Okay, now next is the derivation of the expression for the equilibrium constant. Consider a general reaction in which two reactants A and B are reacting to form products C and D. This is the chemical equilibrium reaction, or we can say the dynamic equilibrium reaction. Dynamic equilibrium, as we studied in our previous topics, that in any chemical reaction there must become a stage at which the rate of forward and rate of backward reaction will be equal, and that point will be called the dynamic equilibrium Representation of concentrations. Concentration of A will be represented by this. This bracket means the concentration of any reactant, or you can see in your book the active mass or molar concentration of A will be equal to this. The active mass or molar concentration of B will be like this. It means that this bracket indicates the molar concentration or the molecular concentration. The active mass or molar concentration of C will be like this, and the active mass or molar concentration of D will be equal to this. Now, according to law of mass action, the law of mass action said that rate of forward reaction will be directly proportional to the product of the concentration of reactants A and B. It means that, as we studied in our previous topic, that rate of forward reaction means that this will be for reactants A and B, because we know that if A and B are two reactants and these are reacting and form the product C and D, it means it will proceed from left to right. So this is one of the point in that macroscopic characteristics of forward and backward reactions, or we can say in the differentiation of forward and backward reaction, we studied that if a reaction is proceeding from left to right, so that will be called the forward reaction. So here the rate of forward reaction is directly proportional to the product of the concentration of reactants A and B. So by applying the law, rate of forward reaction is directly proportional to the concentration of A and concentration of B. We can write this rate of forward like this, RF. So RF will be directly proportional to the concentration of A and concentration of B. If we replace this proportionality constant by Kf, because this Kf is the proportionality constant, so Rf is equal to Kf, molar concentration of A and molar concentration of B, where Kf is the rate constant for the forward reaction. As here is the F, so it indicates the rate of forward reaction. So Kf is the rate constant for the forward reaction. Similarly, for rate of reverse reaction is directly proportional to the concentration of C and concentration of D. As we studied in our previous topic, that if the products reacting back and will give us these two reactants A and B, it means that it is the reverse reaction, or we can say that if any reaction are proceeding from right to left, so this will be the reverse reaction. So rate of reverse reaction will be directly proportional to concentration of C and concentration of D. We can write this R reverse by R small r. So R will be directly proportional to concentration of C and concentration of D. RR is equal to Kr, concentration of C and concentration of D. So this Kr is the proportionality constant for the rate of reverse reaction. Okay, now look at this, where Kr is the rate constant for the reverse reaction at equilibrium state. In any reaction, if there is established the equilibrium point, so it means that at that point rate of forward reaction will be equal to the rate of reverse reaction. So we can write this equation like this: Rf is equal to R small r, where the value of Rf is the Kf, molar concentration of A and molar concentration of B. It will be equal to the value of the R small r, and the value of this R is the Kr, molar concentration of C and molar concentration of D. This will be our equation first. Thus, From the above consideration, it is clear that the rate of reaction is proportional to the molar concentration of the reactants. It means that in any reaction, if the molar concentration of the reactants are higher, so the rate of reaction of that reaction will be higher or faster. If the concentration of these two reactants are higher, so the rate of this forward reaction will be higher. Or if the rate of or if the molar concentration of these two reactants are higher, so the rate of reverse reaction will be faster. Okay, thank you. This was all for the law of mass action.